Today, it's all about things from off-world. Scientists have discovered sugar on meteorites, Europa's ejecting tons of water vapour, and NASA's new Brewery robot is gearing up for tests in the Antarctic.
With Dr. Brad Tucker and Matt Miller. This is Talkin' Science on Trek Zone.
Welcome to Tuesday. Welcome to Dr. Brad Tucker. Brad, happy Tuesday.
Yeah, how's it going?
Really good, really good. We were just saying, as we were prepping to record, that Christmas is so close now. I think it's less than 4 weeks.
It's something like that, yeah. I mean, it's 30 days, right, from today. Thursday, so Thursday's Thanksgiving in the U.S., so a bunch of the American Canadians. So Canada does Thanksgiving, but it's a month earlier in October. But we all get together and do Thanksgiving. So I'm hosting it this year. I hosted it last year as well, but no, it should be fun. The rule in my house, though, because this is the rule Americans obey, is you can't do Christmas decorations or anything until Thanksgiving.
So you're waiting.
On Friday it's fair game.
Well, Friday you go Black Friday shopping, doesn't it?
That's right. Yeah.
And Australia's equivalent is the Boxing Day sale.
It really is, right? I mean, Boxing Day is big. I mean, not Boxing Day, but the day after Christmas is big. That's because of returns. It's not quite the same sale feel as, say, Black Friday.
I love it. All right, well, let's dive into the headlines of the week. We've got 3 very cool stories, pretty much sticking off-planet this week. With the first one, especially, scientists have discovered sugar on in meteorites.
Yeah, and look, when we're talking about sugar here, we're not talking about something you put in your tea or coffee. We're really talking about the sugar family. Sugar is a complex molecule. And when we think about it, it actually forms a lot of the base structure and the base molecules that go into things that go to life. Specifically, DNA and RNA are in this sugar family. And so one of the common sugars found, so to speak, in RNA has been discovered on a meteorite that fell in Australia 50 years ago. So this is actually quite exciting and something we've chatted about before, about where life may have originated. And the fact is that finding this on a meteorite that hit Earth is quite exciting for this potential prospect.
It really goes to the fact that we might actually be not of this Earth.
Look, it's true. I mean, this theory has been around for ages, and it's ultimately, we know what the Earth was like, mostly 3-4 billion years ago. What caused the conditions to start life? I mean, that's not a simple question. It doesn't just happen, magically. Something had to do it. Something had to cause it. And was it a process on Earth that sparked it? Was it actually something from outer space happening? And when you see X random meteorite crashing into Australia, and so this meteorite is the Murchison meteorite found in Victoria, this means something. And, what does that actually mean? Hard to say, but, the circumstantial evidence really increases, let's say that.
And if indeed we have come from another planet, it's probably, life itself has come from out of this world, as it were. It's a pretty apt discovery for this week, especially for the Americans with Thanksgiving.
It is. That's right. It has to come from somewhere, and life moves. And look, it's ultimately the question. And then it starts the thinking, if life came from here and was sparked here with the right conditions, does that happen other places? Does, when we travel to other places, cause this? Can we create life by accidentally going somewhere? All these little sorts of what ifs start to add up and start to being really part of this ultimate big question of where and what is life and where is it from? And look, it's really exciting. This is just another piece in the puzzle, as we were talking about last week with Mars, but ultimately we're starting to really encroach on these big questions of the meaning of life, so to speak, and it's really cool to find it in something like a meteorite, and it's cool that it fell in Australia.
So you're saying the meaning of life might not be 42?
No, it might be giant, big old rock hitting you. I mean, it could be 42 rocks. I don't know.
Well, who knows? But look, speaking of life, it's a bit of a theme going on this week as well. Europa has been detected spewing enough water vapor to fill an Olympic-sized swimming pool every few minutes.
Yeah, when we think about Europa, look, we've believed that there's been water on Europa for ages. And this is going back to a mission that the Europeans sent to Europa about 30 years ago. So we've seen that there's this icy crust under Europa, and it was hinted that there was some sort of liquid ocean underneath Europa's icy crust. Now, the question has always been, is it really that it is ocean, or is it something from Jupiter causing it? Is there a lot of it, or was it just, lucky that we saw it? So a bunch of astronomers used the Hubble Space Telescope and kind of just stared at Europa on and off for about 2.5 years or so, saying, hey, if these eruptions happen, giving clues of water spilling out, it should happen again. And they caught some. So they caught one of these big eruptions, these big geysers, as you said, in the action. And it leads them to believe that if this happens as often as they see it, there has to be a lot of water on Europa, kind of giving another strong confirmation there is an ocean underneath the crust.
An ocean can sometimes, and not necessarily, but sometimes lead to life, microorganisms thriving in that atmosphere, purely because water is hydrogen and oxygen, isn't it?
That's right. The reason people like Europa is it seems a lot like Earth billions of years ago. Earth was this molten core, it cooled down, and then life started, and we had lots of water on it. And when you find places like Europa that seem to be a similar-esque thing, you really have to wonder what's going on, what's underneath the crust, is there more? And look, all the exciting possibilities start to happen. And look, no one knows whether there's life on Europa until we get there and search for it. But again, it just gives you strong evidences of the place to look for. And maybe we're missing this whole thing and we shouldn't be looking for water, but if it happened once, the strong likelihood is it happened again, and you can see that, well, if meteorites hit the Earth and they could have transplanted life here, and we had water, and we know meteorites hit the moons of Jupiter and Saturn and all these other places, and they have water, well, ipso facto, maybe they can create life as well. It's not naive to assume this.
One of the things that I love is that most of what we know about Europa was gathered by the Galileo spacecraft in the late 90s as it went around Jupiter.
Yeah, look, it is an old thing, right? It is something that the data is quite rural. We haven't sent a lot of stuff. Probably as much as people think to Jupiter and Saturn. That was why things like Juno were a big mission. That was the dedicated mission to Jupiter, and that's why Cassini was so successful, because it spent so much time around Saturn. We haven't really explored the moons of Jupiter nearly as well, based on what people are finding, which is leading to the next missions planned to Europa and Titan as well around Saturn.
Well, one thing that we might be sending is the Brewy robot, the Buoyant Rover for under ice exploration. It's heading to Antarctica first for some trial runs.
Yeah, so this is kind of exactly related. When we think about getting to Europa, well, it's a giant ice sheet. It's Antarctica on steroids, so to speak.
For now.
So, yeah. So what are we going to do about it, right? If this ocean does exist and it's underneath the ground, how do we get down there? Well, you have to dig through the ice sheet, and then you need something to actually get underneath this ice sheet and actually look for life or look for anything. And so NASA is about to and is gaming to test a rover, this little robot rover in Antarctica. So they partnered with the Australian Antarctic Division to get down to Antarctica and actually deployed this kind of boring robot-looking clawing thing to get underneath the ice to search for life. And so, it's just another one of these tests that you have to do. You just don't send something to Europa and hope it's going to work.
And sort of how we're using the Big Island in Hawaii to demonstrate, and the Mojave Desert to demonstrate Mars and Martian environments. And Antarctica's doing the same, playing the same sort of role.
That's exactly right. You look for the best analogs you have on Earth, and you test it there. That's as good as you can do before you do your testing to make sure you survive the harsh conditions of space. Because you have to make sure it survives the journey and the temperatures and the pressure differences and all that sort of stuff. But then it physically just has to work on ice. And the best way to do that is in Antarctica. It's what we call integration testing. You can test individual components, but putting it all together and putting in a real scenario is when you actually find the bugs. And these are the important things to do. So it's a simple but very important pathfinder on the way to launching this next mission to Europa, which NASA has said it's going to do.
Europa isn't the only destination that it could head to in our solar system, though, is it?
That's right. It could do Titan. It can do Enceladus on Saturn as well. So there's a few different moons that it could potentially do around Jupiter and Saturn. And look, this is the exciting thing. If you can develop the same thing, this is one of the reasons why the rovers were successful. The instruments on the rovers have changed, but the overall technology isn't dramatically different. But what we saw is that Curiosity or Opportunity and Spirit, one lasted for a decade. Opportunity lasted for a decade. Curiosity, 7 years old now. And so the next Mars rovers are built on a similar thing, size and technology, just, upgraded instruments. And that's why it's going to have a strong likelihood of being successful. Think about a phone, right? You might change individual components of a phone to upgrade the technology. You don't change the whole design every time, maybe unless you're Apple. But you can ultimately kind of keep the similar thing and do small upgrades, because that's how it'll work and improve its functionality. And the same kind of concept is happening in space, which is another reason why space is becoming more and more successful, is applying our industry techniques here on Earth to space.
Fantastic, Brad. Love it as always, talking science with you, and we'll do it again next week.
Sounds good.